Okay, if you want to solve the celebrity problem, that would be great. The celebrity problem goes like this. Like you're given a list of people and the relationship of who knows whom, and a celebrity is one who knows nobody in the group, but everybody knows the celebrity.
Uh, what are you given as the input? I don't think I fully understood that.
Okay, you're given, just like you have a two-dimensional matrix for this problem,
Yeah.
you're given a matrix in that case as well, where each element of the matrix gives you the relationship, as in whether A knows B. If A knows B, then that value is 1, otherwise it is a 0.
Oh, I see. Okay, so you have some A, B, C, D, and you have A going down, B, C, D. And then just, if A knows, well, of course the person knows themselves, so that one's always 1.
Yeah, whether the person knows himself, you can either you can assume whatever you want, it doesn't matter. But essentially, a celebrity is one who doesn't know anybody, but everybody knows the celebrity.
I see. And then it becomes, this one means A knows B, A knows C, and then I guess A knows D, right? So right off the bat, you know that A is definitely not the celebrity.
Yeah.
Because it knows everybody else. So this problem sounds slightly familiar, but I don't really remember the approach that you would take. So maybe I did this at some point, but it was way long ago. So yeah, I guess I could definitely try it.
Okay.
Right. So we're given a matrix, and we want to find who the celebrity is, right? And basically, that just means that this person doesn't know anyone else, or they don't know everybody. Hello?
Yeah. What's the question? What's the question?
So what was it that the celebrity doesn't know anybody else?
Yes, both conditions have to be satisfied. The celebrity doesn't know anyone, and everybody knows the celebrity.
I got it. Everyone knows the celebrity. The celebrity doesn't know anyone else. Okay, so for the celebrity doesn't know anybody else, I imagine that one we can definitely find pretty quickly, right? If there is any person, so I guess thinking of it naively, what you could do is go through every person in the matrix and determine if the count of the number of one set is just 1, right? Because the celebrity will still know himself. So if it's 1, that means that person is a candidate for the celebrity, but then you also have to satisfy that everyone knows the celebrity, right? So what you would have to do is go through the celebrities column and verify that all of the numbers there are 1, right? So if the celebrity was C, these would all have to be 1 in order for the person to be a celebrity. So if there are n people that we have, everybody knows the celebrity. We can verify this in big O of n runtime, right? Because all we're doing is just going through that single listing. But if it turns out,
how do you know?
This is once we have the candidate, right? So really the steps are really in the opposite direction. So this is step number 1, and this is step number 2. The celebrity doesn't know anybody else. The way that I mention it, this takes n times n runtime, right? So I'm guessing that's or n squared, because we know that it's an n by n matrix. So I'm guessing the optimization that you would want to do, because this definitely seems like the naive approach is to just scan through, right? I'm guessing you'd want to bring the n squared down.
Yes.
So how would you do that portion? So if you were to reduce the complexity from n squared, the next logical step is usually that you want to do linear time instead, right? And typically when you do that, you try to save some data somewhere. Usually it's say like if you want n time, you would save an n length matrix of some previous computed data, right? But does that help us in this case? I'm thinking of normally when you have like a dynamic programming problem, you would store the solution at each interval, right? So what we would save if it's a dynamic programming problem is in the end, after processing all n people, we want to know who is the candidate given the number of people we've gone through so far, right? So if that's the case, instead you would have an n-length array where at each index you would store who is the candidate given the number of people we've processed so far. Is that something that's possible to do using just, say, I guess if there's n steps, that means that you have to do it in a constant time at each step, right? So let's think of what the base of this would be. Say we start from A, right? So we look at A, and he's the candidate because he's the only person possible so far, right? So let's say with the 4 characters we have an n-length matrix and stores candidate given n possible or given x possible candidates, right? So at the first step, it's definitely A because he's the only person there. Let's try and make an actual example table just so that I can, run through it. So let's say that in the end, C is going to be our celebrity. So we'll just set this row all to zeros. And then B is going to be just a normal person. So everybody knows C, right? B, let's say, knows A, but then, no, B doesn't know A. Just to make it a bit different from the first one. B, of course, knows himself, and B knows D. Let's say B doesn't know anybody else, right? Yeah, this looks like, some arbitrary assignment. I don't know if it makes a difference for other cases. I think I'll have to make a separate test case in the situation that there's maybe no celebrity. But I don't know. I'm not. Yeah, I think I'll come back to that.
Corner case. Yeah, that corner case is probably not that relevant right now. We can solve the.
Yeah, I think I can come back to that. Yeah, just because they are 2 separate steps, right? So here I get to my index 1, and I know that so far my solution is A. But then in order to check whether A is a candidate, he would not have to know anybody else, right? So if I were to check against the 2 possible people, if I say that B knows A, B knows the candidate, that doesn't really give me any information, right? Because he's already my candidate. So if I say that A is the celebrity at the 0th index solution, then me saying that B knows that A is a candidate is no extra information that I've gained at this step. But if it turns out that A knows B, then A is definitely not the candidate because there's no way, right? So at this stage, because B doesn't know A, I think, oh, wait. So there's 2 possible things. I guess if B doesn't know A, then it turns out that A cannot be the candidate, right? But if A knows B, then A is also not the candidate. So I should write that as this one, which is B knows A, or doesn't know A, then A is not the candidate, B is candidate, case 2, A doesn't know B, which means that A is still the candidate. I don't know if that, can you have one and not the other? I guess those are both the same case, right? No, that's not true, because what if they both know each other, then you would, can you have that both of them don't know each other at the same time? No, that's impossible, right?
Yeah.
No, that is possible. That is possible, because if it turns out that if it happens to be, let's say D is set to 0, right? A doesn't know about D, D doesn't know about A, but this still has a candidate. So
Yes.
I think we would need both of these cases then, and it's instead of just one. So if it turns out that B doesn't know A, sorry, what do we have in this one? We see that B doesn't know A, then A is not the candidate. So right, we updated our candidate to being B, and now we get to C, right? And again, it turns out that C doesn't know about B, right? Which means that C is the candidate. So I'm trying to get this case 2 to happen sometime, because this is true, but A doesn't know B. Oh, okay, this case comes up right here. C doesn't know D, then C is the candidate. And so when we return our solutions rate at, n-1, we get C, which is the correct solution. I want to say that this is probably the thing we can do in order to find out if the celebrity doesn't know anybody else. And the reason it should work out is, let's see, we're going through, and the only way that someone could possibly be selected is if it turns out that they don't know anybody, right?
Yeah.
If you have a candidate, at some point, that candidate, if it's not the celebrity, is going to find another person that they do know. And so let's say you have some, as soon as you find that person that is actually the candidate, nobody else will know them, or they won't know anybody else. So they'll remain the candidate until the very end, right? So is it required to say that, so that covers step 1, right? Is it really required to say that everybody, the second step, that, everybody knows the celebrity, or do we just get that through from the traversal that we did?
No, I don't think you get it from the traversal that you did. You have to do a separate check for that.
Okay, let me think about that. So when we go through, we haven't really done a verification, right? That everybody knows the celebrity. All we've said is that this person that we have as the candidate, it doesn't know anybody else. So we already talked about how we can do the everybody knows the celebrity. So I think given that, this altogether does end up being a linear time solution. I've used this extra space, but it seems like I only need, say the last index. So instead of using n space, I think it's fine if I just, keep the last element. Which would give me down to a, it's big O of n runtime complexity and big O of 1 space complexity. Cool. So given this, is it okay if I code it out? Hello?
Yeah. Sorry.
Is it okay if I code this out?
Yes, please.
Okay, cool. So celebrity on some nose, right? Let's see what we decided to do. We had our candidate, which is just set to it's the matrix. So I guess instead of just the matrix's values, I also need the people, right?
I don't think you need the people. You just, given a matrix, you can just use the indices as the people, right? You don't need a.
Oh, so it's not actually letters. I can just say the index of the person. Got it.
Just return the index of the celebrity.
Okay, so my candidate is 0. Then in the end, I'm going to want to return the candidate, potentially. So the first step is to go through and determine who my final candidate is, right? So what I said is for int in range 1 to n. What I'm going to do is it's separated in two cases, right? If it turns out that B doesn't know A, so B is the person I'm comparing to. Yeah, so it turns out the matrix of, it turns out that B doesn't know A. In that case, I update my candidate to being the index, which is B. If it turns out that A doesn't know B, it's not matrix candidate to int. In that case, I guess I don't do anything because it turns out that I'll just set candidate is still the same, right? So I can leave out that condition. That seems like actually the entire translation of the idea in the code, just because I can leave out the second case. So going through here, this should find me the candidate. And now I want to know if everybody knows the candidate. So for int in range n, I'm going to say if not matrix of what is it? Person knows candidate, then I guess is it safe to return -1 to say that there is no celebrity? Okay, in that case, I'll just say that there is no celebrity with -1, and my candidate here at the bottom should be the same as what I had from the earlier for loop. One thing, some cases I might want to think about is what if it turns out, is it possible to have multiple candidates at the end, multiple celebrities? Not really, right? That breaks the definition. Yeah. Because you'd end up having what's it called? You'd have you wouldn't have a person who doesn't know anybody else, right?
No, there could be a person who doesn't know anybody else. In fact, the celebrity doesn't know anyone.
No, I'm saying if there's two people that don't know anybody else. Sorry, correction. It's not that there'd be no one that doesn't know anybody else. There wouldn't be anybody. Everybody wouldn't know the celebrity, right? Because there's one person that doesn't know the celebrity in that case. So I guess that case is covered. Is it okay if I run this on some test cases?
Yes, please. Yes, please.
Okay, so let's call our matrix. Let's do the one I had from before, which is 1, 1, 1, 1, 0, followed by 0, 1, 1, 1, 0, 0, 1, 0. And 0, 0, 1, 1. Celebrity on the matrix. This one should give me a 2, right? Oh, forgot the commas. Cool, so that one's okay. The test cases that are I'd also want to check is if it turns out that I don't have a celebrity at all, right? So in that case, let's see, I have this person, C, that doesn't know anybody else, and I also have D that doesn't know anybody else. For this one, I should get -1, and I do. So that works out. For other edge cases, I think this pretty much ends up being most of it, unless it turns out that I have an empty array, in which case I would return 0. I'm guessing for an empty array, I should probably return -1 as well, right?
Yeah, that's small.
Got it. So, yep. So if n equals 0, then I return -1. Which, I mean, I can print it off, but it should be, oh, I guess at minimum it's going to be, a single item, right? Yeah. Unless the input is this type. So really, I would say that if n is equal to this, I return -1. Because I think a single item doesn't count as valid input.
Yes.
Oh,
yes, true. It should be a square matrix.
List index out of range. I'm guessing this happens with, yeah, it happens with my last test case. Matrix. Or, yeah, I could really just say if n equals 0. Oh, it's 1. Right. Cool. So I guess given that, yeah, final solution.
Awesome. Great. I mean, perfect. You're really fast at this and very logical style of thinking. That's really good. No other real feedback I have. I mean, it's all good.